now we are going to talk about building images. So first, we are going to build images interactively. So, kind of spoilers. The method that I'm going to show you now is going to be kind of manual and imperfect. This is not something that we would usually do. So you might wonder, well, why are you going to spend time showing that to us then? Well, two reasons. First, I think this is going to be really helpful to understand how things work. And the second thing is that this will be a good opportunity to see a couple of more advanced commands. All right, let's dive in. My goal is to build an image that will have the Figlet program embedded into it. Remember my little Figlet hello world that shows these big ASCII art letters? I want to build a Figlet image. All right, so first method, I'm going to do docker run -ti Ubuntu. So I want an Ubuntu container, and I'm going to do things manually. So imagine I'm playing a video game, basically. I'm like, okay, start the level Ubuntu. And now I'm like, all right, install apt-get update, like I did a couple of hours ago, apt-get update to get the list of packages. And now I'm going to do apt-get install Figlet. All right. So now I have Figlet, so I can do Figlet, yay, it works, awesome. And now I'm going to save game, if you will. So I leave the container and see how my container is a 509f, etc., etc. I'm going to do docker commit. So commit, it's like a git commit, when you're committing your code to a repo. So this is the way to tell Docker, hey, stop, take a snapshot. Imagine like take a picture, save game at that particular point. So 509f. And here I'm going to give the name of the image. So let's call it Figlet build. So that means image Figlet with tag build. And there we go, I just created a new image. Nice. So now I can test it. I can do docker run -it Figlet build. Okay, so I get a shell in my container. And now if I do Figlet let it snow, it says let it snow. Let it snow, like this. Yeah, better. Okay, so I just created an image with Figlet installed. Now, couple of interesting things is that instead of doing a Docker commit, or rather before during the Docker commit, I could do, for instance, a Docker diff on my container. And when I do Docker diff, it's going to show me the diff, so the difference between the image and the container. In other words, it's going to show me all the files that were added, removed, changed between the image and the container. Or to reword that yet another way, this is going to show me all the changes I've made, like what's the result of my apt-get update, apt-get install Figlet command. So this Docker diff, at first you could think, okay, yeah, that's a nice novelty command, but what is there any real purpose for that? Yes, this command is actually awesome for at least two use cases. Okay, you know what? I'm even going to give you three use cases. First use case. Let's say that I install something with a script. I don't know if you already met that kind of program. They tell you, hey, you just run this script and it's going to install everything for you. Run.sh or install.sh. Or sometimes you have a command, like curl blah 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 pipe sh or whatever. So anyway, you have this kind of magic script and you don't exactly know what it does, but you really would like to know. Then Docker diff is going to be super helpful with that, because you run the script in the container and then you do Docker diff and you see exactly what was installed, what was changed. Super convenient. Okay, second option, second use case, this is going to be about security. So there is a whole bunch of attacks on web services that happen in two steps. Like, you know, the end goal is to take over the web server. Let's say I'm an evil attacker trying to hack my way into a web server. So my end goal is to run arbitrary code. You know, sometimes we talk about like arbitrary execution vulnerability. When you see something like that, like arbitrary execution, it means, oh yeah, somebody found a way to execute arbitrary code. So in other words, to run whatever they wanted on the server. So that's bad, because it means that basically they took over the server. So very often, to get there, it's a two-step process. The first step is that you find a way to upload the code to the server. And sometimes it could go kind of in roundabout ways. You know, you could, maybe there is, imagine like a website that lets you upload a picture. Maybe it lets you post pictures or upload your avatar or whatever. So first step is I'm going to upload a picture which actually is not a picture. It's going to be a program that I want to execute. And then I'm going to use another problem somewhere to trigger the web server to execute that. So it's two-step process. Okay. So what's the point with this Docker diff? Well, with Docker diff, I can try and detect if there are some files that got added in my container. You know, like, so now I'm not thinking about building a container anymore. I imagine I have this container running a web server, like it's running my code, and I want to do a little kind of health check here. I want to check if everything is fine in that container, and I'm going to use Docker diff, and then look, oh, surprising, I have some really weird files here. I wonder what's going on here. So Docker diff could be used as a kind of security audit. You know, like conceptually, that's the equivalent of walking into the office and checking if there is anything weird going on. Or, you know, like as we say, like, oh, don't leave your luggage unattended in public transit or whatever. That's kind of the equivalent. We do a Docker diff to see if there is anything weird lying somewhere in the container. And the third use case is taking that to the next level. One thing you can do is run read-only containers. So, example, I can do -- read-only Ubuntu. At first, it looks like nothing changed, except now if I try anything that would write the container, it's going to block it. It's going to say read-only file system. And yep, it won't let me. So I can run a read-only container. This is great for security purposes, because now if I go back to my previous example of security attack, now I'm the bad person trying to get into the system. The thing where I put my payload, my hostile program, it just doesn't work. It gets stopped right away in its tracks because the container is read-only. Okay, what's the link with Docker diff? Well, the problem is that there are many programs, many services that would not work in read-only mode. Example, my program where I upload a picture to, for my avatar or whatever, it would not work anymore with a read-only container. So if I want to get to the point where I can run in read-only, I could have two strategies. One strategy is enable read-only and see what breaks and fix it. Another strategy is we don't enable read-only, but we're going to run docker diff once in a while and see what files have been created. And then I could notice, oh, I see some images here. Oh yes, because my users are uploading pictures. That's normal. So then I could refactor my code, and instead of uploading the files to the file system, I could send them directly to S3 or some cloud storage or whatever, or I could, refactor that one way or another. Even like, I don't know, I could put them in the database, but basically make sure that I don't write them to disk. So that's where Docker diff can be pretty useful. Now, technically, what Docker diff does is that it looks at the read-write layer. Remember, I have all my layers, like my sheets of glass stacked on top of each other. And on top, I have the read-write layer on which I can actually read and write. And what Docker diff does is list the content of that read-write layer. All right, great. So now if I do Docker images, yep, I can see Figlet tag build that we built like 8 minutes ago. Awesome. But as I was telling you, Docker commit is a very manual process. Here it's kind of easy because all I did was apt-get update, apt-get install, done. But imagine if it's something more complicated than that. Imagine I'm installing Python or Node or Ruby and a bunch of dependencies and getting a bunch of code and building stuff, etc., etc. If I need to redo that all the time, it's not going to be great. Like if I need to reinstall everything every time, that's not going to be a great experience. And so that's why we're going to introduce a better way to build images, Docker files. Okay, so what is a Docker file and how do we write one? A Docker file is a recipe indicating how to build a container image. That's it. Now, if imagine we meet in an elevator and we have 1 minute for me to tell you how to write your first Docker file. This would be my advice. If you need to write a Docker file, first you start by writing a shell script with all the commands that you want to run. Then you add run in front of each line, and finally you put from on the beginning of the Docker file to indicate from which image you want to start. Okay, maybe that seems a little bit confusing when I explain it like this. No, let's see with a concrete example. Let's see what that looks like. So I'm going to make a new directory like my Figlet image and go there and create a file called Docker file. Oh, by the way, when you will need to edit files, you have a few options. If you already know how to use VI or Vim, you are of course welcome to use that. If you prefer another Linux editor, you are welcome to install it, apt-get update, apt-get install, whatever you want. If you're not super comfortable with the Linux command line and you're like, oh, how am I going to do this? One thing you can do if you're using VS Code, there is a way with VS Code to edit remote files on a remote machine. I'm unfortunately not an expert VS Code user myself, so I would not be able to tell you exactly how to do it, but I know that folks using VS Code use that technique very often, and that's what I would recommend if you don't feel comfortable with VI, Vim, and things like that. And if you need help with that, feel free to ping us in the chat room as well, and this afternoon we'll be happy to help you one-on-one if needed. All right, so I'm going to create a Docker file and I'm going to follow my own advice of earlier. Step 1, pretend that I'm writing a shell script. So I do apt-get update, apt-get install Figlet. So that's the instructions that to build the image. Step 2, I'm going to add run in front of each line. Okay. Step 3, I'm going to add in the beginning from and the image that will be my base image. So Ubuntu. And that's it. That's my Docker file. Let's try it out. So now, how do we build? Well, Docker build. Now, when I do Docker build, I need to give 2 parameters. First, I need to give the directory where the Docker file is located, and that's going to be the current directory. So that's going to be dot. And then I need to give the tag with -t. So how do I want to tag? How do I want to name my image? And I'm going to call it Figlet Dockerfile. So you can see it's executing the apt-get update. Now it's executing apt-get install Figlet. And that's it. It says successfully tagged Figlet Dockerfile. Cool. Now, immediately, one really cool thing I want to show you is that if I run the same command again, boom, it's instantaneous. And that's one of the really nice things with Docker build. This is called the build cache. And you can see on every line it says using cache, using cache. Okay, let's go back a little bit to that Docker file and explain how that works and what's going on. So we give a starting point, and then we give instructions. And what Docker will do is that, I'm going back to my video game metaphor, but basically it's going to save the game after each command. So from Ubuntu, then run apt-get update. I think somebody just connected to the same VM as mine. So apt-get update, apt-get install Figlet, and just, like between quotes, like save the game after each step so that we can resume from that step later. Example, let's say that instead of installing Figlet, I want to install, what could I install actually? Let me try to think about a simple example. Maybe like ZSH, for instance. So that's, whoops, sorry, ZSH. Yeah, okay. So now I do Docker build, and what you can see is that it was able to skip the apt-get update section. It was like, no, using cache, we're good, we're fine. I don't need to do apt-get update again because we did it before, so I can resume from that checkpoint and just run the apt-get install ZSH. Okay, now if I go back here and I put back apt-get install Figlet and I do Docker build, boom, instantaneous, because we've done this before and Docker knows what happens when you do that. So it has a cache. Imagine like almost like a series of chemistry equations, like this image plus that command equal that new image. So Ubuntu plus apt-get update equal that image over there. That image plus apt-get install Figlet equal that image over there. So each time that we run a command in an image, it's going to look up in that cache and say, I know how to do this, and use the cache. Excellent question. What happens if the cache has stale data? Imagine, for instance, I set this VM aside and I come back in 6 months and I Docker build again. It would build immediately. And I'm like, wait a minute, there's probably some update to the Figlet package or even like the Ubuntu image. So what's going on here? Well, we have 2 options to help with this. First, there is the kind of brute force approach, -- no cache. And when I do that, it's going to just rebuild everything. Okay, so that's option number 1. It works when you really need to, completely ignore the cache. option number 2, I can use --pull. So when I add --pull, it's going to try to update the base image. Now, between when was it, like 2 hours ago, when I pulled that Ubuntu image, so between 2 hours ago and now, there was no new release of Ubuntu, so this doesn't pull anything, so nothing special happens, and then it uses the cache. But if I time travel, fast forward 6 months later, there is a pretty good chance that there will be a new Ubuntu image. And so my --pull is going to pull that new Ubuntu image. And then, since I have a new Ubuntu image, it's going to rebuild the next steps as well. So, like my personal recommendation is that if you have some automated build system somewhere, --pull is probably the right thing to do there, because it's going to be a pretty good compromise. It's not going to rebuild everything every time, but whenever there is an update to the base image, it's going to rebuild everything else. And now locally, if at some point you're like, hey, no, I really want to force a rebuild here, then you can use the --no cache. I'm going to be honest with you though, I almost never use --pull and --no cache. I'm not saying that it's I'm not saying that they are useless or whatever. I'm just saying that in my day-to-day work with Docker, I almost never need them. So just FYI. Okay. What else is interesting here? Yeah, so that way of describing how to build images, this is extremely powerful. And if we try to express in a kind of not exactly scientific way, but if we compare to the other methods that we have to build an environment, I'm not even talking like containers, but generally speaking, I want to set up a server. What are my options? Of course, there is doing it manually, create the server, and then I SSH and I run a bunch of commands, and at the end I'm like, yes, I installed my machine. Not great, because it's a manual process and I want to automate things because I want to be an efficient DevOps engineer, etc., etc. Okay, so what's my next option? I could write a shell script. So I write my nice install.sh, and in my shell script, I put a bunch of commands and I run the script and it runs everything, and yay. So this is simple because I just have to write the steps. The problem is that it won't be idempotent. So idempotent, what is that? Initially, it's a mathematical term for a function, which means that you can apply that function 1 times or n times, and the result will be the same. Example, the function multiply by 0, that's idempotent, because if we take something and you multiply by 0 1 time, or if you multiply by 0 10 times, yeah, the result is still 0. Another example is that some commands are idempotent. For instance, apt-get update, you do it once or you do it twice or 3 times or 10 times, it's going to be the same. Now, some commands are not idempotent. So here it's a nice example because all these commands are idempotent. If I put that in a shell script and I run the shell script, and if I run the shell script multiple times, we're good. Now let's get another example. Let's say that in my script, it's a script to set up a server, and I put something to create a user. So I could use the command, like user add Jerome. So if you do that the first time, it's going to be, yep, I create the user. Now, if you do that the second time, it's going to tell you, nope, that user already exists. This is an error. So if I want to make that idempotent, I need to do something like, if user Jerome exists, then user add Jerome. No, sorry, if it doesn't exist, doesn't exist, So in concrete terms, if I really had to write a shell script for that, I would probably do something like grep-q Jerome /etc password or user add Jerome or something like that, something along these lines. So it means that if I'm writing a script, now I have to start to kind of pepper that script with all these extra instructions. And of course we can do it. I mean, if you are a sysadmin or if you have automated deployment and installation, you probably have done that lots of time, but it's extra work. It's not great, and sometimes it's going to be more complicated than that. So option one, we write shell scripts. Option two, we use configuration management. We use tools like Chef, Puppet, Ansible, and with these tools, it's pretty powerful because you can say, I want this user to exist, I want this package to be installed, I want this, I want that, and the tool is going to kind of translate that into specific instructions. The advantage is that this is designed to be more idempotent. This is designed to kind of reconcile your configuration and the state of the machine. The downside is that it's a new tool that you need to learn, and it's often pretty complex. So if I get out of the server installation example and I talk about something more familiar, let's say that we want to meet for lunch in a specific location. Well, I have two ways to do that. One way is that I could give you the exact address or GPS coordinates, and then we all figure it out. So that would be one option. That would be like the configuration management option. You indicate exactly, okay, we want to meet there, and then you have a pretty complex system because you need GPS and you need maps and you need like an algorithm to find your way from where you are to the destination. So it's pretty complex, but it feels kind of universal. If I give you an address, we can all understand where that is and find a way to get there. The other option is I could tell you, hey, let's meet at that place. Okay, let's pretend that we all work in the same office. Could say, so to get there, you leave the office, turn left, you walk 3 blocks, then on the right, and then there is a roundabout, and it's going to be on the left. So this is the script way. It's very simple. You don't need to have a GPS. You don't need to be able to read a map and know where north is, etc. You just follow my instructions and you arrive at destination. Except this only works when you have a known starting point. Like if we leave from the office, yeah, that works. But imagine even in the simple scenario where the office has 2 exits, if you leave from the wrong exit and you follow my instructions, you're going to end up in a completely different place. So what Docker does is that it's trying to reconcile both, where you give simple instructions, like commands to execute, but you give a starting point. So if I go back to my GPS and meeting point example, that would be like saying, hey, you start from this well-known place, maybe I don't know, like the McDonald's right across the street from the office, and then you go to that direction and left and right and etc. etc. So you give this well-known starting point so that everybody knows, okay, yes, this is the starting point. We know where the instructions start, and then you go from there. And that well-known starting point, that's the from that we have here. We say from Ubuntu, follow these instructions. So we get kind of the best of both worlds in the sense that we have some, let's say, relative simplicity. I always say relative because we have to be careful when we, with computers and programming, etc. Always be careful when somebody says, "Oh, it's easy. You just have to," etc., etc. For some folks, it might indeed be easy and etc. But for some other folks, it's like, no, that doesn't seem easy at all. So I always try to say it is relatively easy or comparatively easy. because all we do is write commands that we want to execute in the container, but we get all the nice advantages of config management, in the sense that if you build multiple times, it's idempotent. There is this caching mechanism, and so yeah, we get the best of both worlds basically. One particularly very interesting strength of that system is all in the caching. Like really, especially when you start to have more complex stacks, you will see that it's super convenient to be able to rebuild the stack in seconds, even if it's a big stack with like Java and 1 million dependencies, etc., etc. Once you know how to write the Docker file the right way, it's going to be really fast when you make changes there and you rebuild. Okay, so that's kind of the, a little bit like the sales pitch for Docker files. Now, I want to show you I don't want to say the bad side of Docker files, but okay, first maybe questions. Is there a way to specify a line of the Docker file to not cache? Excellent question. So for instance, if I have a line that pulls from a Git repo, and the answer is not really, but we're going to see this morning, well, afternoon or evening, depending on where you are, but we're going to see today how we deal with that particular scenario. We will see that, for instance, when you have when you need to pull from a Git repo, we're going to work around it by not pulling from the Git repo. We're going to use a different way to get the code in the container. This is a very good question, and we're going to see in a little while how we work around that. But in the general sense, no, if there is one particular line where you want to say, okay, skip the cache from that point, there is no nice way to handle that. There is kind of a way to do it, because we could use like a random file, etc. So that there are some hacks to do it, but clean ways, not really. But we're going to see like the exact example that you're talking about, like getting stuff from our Git repo. We're going to see that in a moment. All right, now the bad sides of Docker files. So if I build this, it's instantaneous, it's great. Now let's see what happens if I make a really small, tiny, ridiculous change, like I'm going to put an extra space here. And that doesn't change anything to the result. Like if you put extra spaces in the command, it's going to behave the same way, but the Docker builder is not smart. It thinks that this is a different command, and it doesn't use the cache. Even if I add one more space, again, it's like, oh, this is a different command, so I'm going to run it again. At first, we could think, well, this is really dumb. It could figure out that this is the same command. Well, no. So we need to be careful here when we build systems. Usually it's a bad idea to have a system that is too smart. Okay, what does that mean, too smart in that case? Well, I'm going to give you another example. Let's say that we have a Docker file where we do apt-get install pkg1 and pkg2. Okay, now let's say that we replace that with apt-get install pkg2 pkg1. So if, for folks not familiar with apt-get, the order of the packages does not matter. So install pkg1 pkg2 or install pkg2 pkg1, that's exactly the same thing, same result, but the Docker builder doesn't know that. So if we make that change, it's going to rebuild. So I could be like, the Docker builder could be a little bit smarter than that. Well, let me show you another example. Now I do run, copy file1, file2. Now let's say I replace with run cp file2, file1. So now this is not the same thing at all. In one case, I copy file 1 to file 2. In the other case, it's the other way around. So the result is absolutely not the same. So imagine if we wanted the Docker builder to be smart enough to do the right thing, it would have to make the difference between these two scenarios. It would need to know which commands commute, mathematically speaking, in which cases I can switch the parameters and in which cases I cannot. We are humans, and we are the end product of like billions of years of biological evolution, etc. So we have like bajillions of neurons up there, and we know that some commands commute and some others don't, and that's great. But the Docker builder is a pretty simple Go program, and it cannot make these differences. It cannot know which arguments commute and which ones do not. So all it does is compare strings. If the line, if the run line is the same, then it's the same command. If it's different, even if the difference is tiny, then it's a different command. It doesn't try to be smart, and between us, I don't think it should. All right. Okay, so that's one thing. So at first it looks like a I don't want even to say a bug, but it could seem like a shortcoming of the Docker builder. But once you know why things are like that, I think it makes a lot of sense. All right. So we've done that. We've done that build. Yes. Now, if you run that build on a Mac or Windows machine, the output is going to be a little bit different. It's going to look like this. Don't pay attention to that little extra thing I'm adding here. But if you run on Mac or Windows, the build will look like this. And I don't know if you can see the difference. I mean, you can see that it's kind of different, right? First, this is blue. I don't know if you can see the colors very well, but this is navy blue instead of black. We have timing information here. If I build again, it's going to use the cache and be super fast. So why is that? Why would it be different on Mac and Windows? This is because on Docker, we have two generations of build systems. We have the old style builder, which is the one that you saw here, first one I show you. And then we have the new style builder, which is called BuildKit, and which looks very different. I'm going to tell you more about BuildKit on Friday, but for now, all I want to know is that BuildKit is like a completely new re-implementation of the build system. It behaves the same way, and it feels very similar, a little bit like going from a classic gas-powered car to an electric car. It's like, well, they are both are cars. They have four wheels and a wheel and like pedals to make it go forward and stop. But if you look under the hood, like literally, it's completely different. In one case, you have like a combustion engine and etc., etc. In the other case, you don't have a combustion engine. You have batteries and so. This is the same idea. It's the same result. At the end, you have something that builds container images using a Docker file, but the implementation is completely different. Now, why would it be different between Linux and Mac and Windows? Now, this is a tiny little detail. When you are on Mac and Windows, by default, it's going to use the new BuildKit builder. And so you will get output like this. When you are on Linux, the default is the old style builder that looks like that. But as maybe you started to guess thanks to that little thing here, you can switch between builders with that environment variable. You put Docker BuildKit equal 1 to enable Docker BuildKit, or you can put Docker BuildKit equals 0 if you want to disable it when you are on Mac and Windows. For now, I just wanted to mention that so that if if some of you are building on Mac and Windows and you see a different output, I do like, what's going on? So I just wanted to explain what's happening, but we're going to talk more about BuildKit on Friday because it's a more advanced topic. For now, we don't care that much because again, it drives the same way. They both take Docker files and they create images and that's it. All right. So we did that. Caching system. We talked about the caching system. Now there is a very interesting command called Docker history. And Docker history, between us, I think it should have been called Docker layers because it's going to show the layers of an image. So I can do Docker history Figlet Dockerfile, and these are the layers of the image that we just built. So you can see the newer layers are on top and the older ones are at the bottom. So these two layers, you can see like 3 weeks ago, these are the layers of the base image, of the Ubuntu image. So we have 2 layers here. Okay, now we have 1 layer for apt-get update, 1 layer for apt-get install Figlet. So you can see that, to simplify things a little bit, every line in my Docker file is going to translate to a layer in my Docker image. Apt-get update, apt-get update, apt-get install Figlet. Okay, cool. Now, one little detail, if we look at the size here, I'm like, Figlet, that's 1.55 megabytes. Now, apt-get updates, that's almost 40 megabytes. It's a little bit too soon to start talking about optimization, and there is a quote by Donald Knuth, which is like a very famous computer scientist, like who wrote like lots of algorithms and a really well-known book about algorithmics, etc. And so this famous quote by this guy is, premature optimization is the root of all evil. So what this means is that before trying to make it fast, you should make it right. Make something correct that works, and then you can start thinking about optimization. So I'm not going to talk about optimization yet, like the fact that we just built an image that is how big? Figlet Docker file. It's almost 120 megabytes, so that's kind of big, even though the Figlet program itself is only 1.5 megabytes, so I feel like there is a lot of overhead in that image, and I will want to optimize that, but not now. This is going to be for Thursday, but there will be something to do here. I just want to draw our attention on this. And I would like to compare that history, like these layers, with the Figlet build that we did earlier. I don't know if you can see the difference, but the base layers here are the same. This is the layers of Ubuntu, but here I can see independently, like individually, the layers created by the Docker file. Each line of the Docker file, apt-get update, apt-get install Figlet, great. While here, all I see is bash, a single layer, no details, because what I did here is that I got in the, I created a new container and I ran a bunch of commands, and then I ran docker commit. If I come back one more time to my video game metaphor, it's when I have a Docker file, I'm kind of saving my game after each line of the Docker file, while in that scenario, I didn't save anywhere. I mean, only at the very end. I did all the steps, and only at the very end, I save game. So, right. What else? Yes, little detail. So I don't know if you see here, we have created by bin sh-c apt-get install figlet. I'm like, what is this bin sh-c? Why not just directly apt-get install figlet? Like, what's going on here? Well, heads up, this is going to be a little bit advanced, but also pretty useful when working with containers. To explain what's going on here, I'm going to talk a little bit. Let's talk about Unix. When you want to run something on a Unix system, for instance, I want to do ls-l/tmp, list the content of /tmp. Wow, I have stuff in that /tmp, right? So what happens is that I'm going to execute something like this. I'm going to have a system call, which conceptually is going to look like this: exec ls-l/tmp. It's not exactly that, but close enough for the purpose of this explanation. So what that means is that there is something somewhere that take my whole command, ls-l/tmp, and which is going to parse it into ls-l/tmp. And if I do something like ls tilde/docs, for instance, there is going to be something that will transform that into ls, and tilde that's going to be replaced with my home directory, so /home/jerome/docs. So there is something responsible for this transformation, for this parsing. And that thing, in that case here, that's the shell. The shell that lets me interact with the machine is the one that's going to, kind of slice this command line and then execute the command. Okay, so what's the connection with my Docker file and with sh-c? Well, the connection is that same thing in my Docker file. When I have run apt-get install figlet, I need to have something to transform that basically into apt-get install figlet, to do this parsing, to do this slicing of the command line. And the easiest way to do that is to offload that job to the shell. So basically, I would execute sh-c and then my whole command. And so sh-c, the -c, I think it's for command. So it's to indicate I'm telling my shell, hey, execute that thing. Pass that command, slice it, replace the variables, do whatever you need to do, and execute it. Okay, so what Docker does when I give it a command, like apt-get install figlet, it's like, well, personally, I don't know how to parse that and how to interpret it, so I'm going to offload that job to the shell. I'm going to execute sh-c and whatever you give me, and I'm going to let the shell figure it out. And so that's why when we look, sorry, at the other one here, I can see this bin sh-c blah, blah, blah behind it. Okay. Now, something potentially interesting is that if I'm, if I want, I can also tell Docker exactly what I want to run. And it works like this. So we call that the JSON syntax because in JSON, that's how you would specify an array of strings or a list of strings. We use square, like angle brackets. Then we put strings, so double quotes, and we separate them with commas like this. So in that case, I'm telling the Docker builder, hey, you don't need to call the shell. I got you. I'm going to do the parsing myself. This is the exact command that I want you to execute. You don't need to do that sh-c thing. Now let's see what happens if I sorry, I need to actually make that change in my Docker file, not in some random file that I just created. So let me make my changes again. apt-get install Figlet, there we go. Now I'm going to build that, so docker build dot -t Figlet :JSON, for instance. First thing that you can see is that it's not using the cache, because for Docker, that's a different command. And now if I do docker history Figlet JSON, you can see that now it says apt-get install Figlet. It doesn't show sh-c. Okay, now you may ask, what's the point? And you would be extremely right. Like, honestly, when you do a run, there isn't really any point, any advantage in using that JSON syntax. Okay, so why is it interesting then? Because after we're going to do a short break in a few minutes, and after that break, I'm going to introduce other commands like cmd, entry point, etc. And for these commands, it's going to be interesting because it will let us skip the shell and directly run the program that we want. All right, poop, poop, poop. We did that. Perfect. We're good on timing. So, do you have any questions before we take a short break? So is it possible to split and compose Docker files, and are there some best practices for when it becomes too big? Excellent question. So I will say yes and no. I'm going to start with the bad news. The bad news, we don't have something like a hash include or something like that. We don't have a way in a Docker file to say, okay, include that Docker file and now do this and do that. So that's the bad news. Now the good news is that we can still compose things together. So for instance, if you want, you can build your own base image and then use that in a from example. So I have a little repo. Let's see if yes, that's it. No, that's not that. Pretty sure it's called, I call it foundation example. Yes, that's it. So I'm going to put the link in the chat. This is an example where we have two applications that are using some common stuff that we put in a foundation image. So here I have this foundation image where I kept something really simple here. Oh, just let's use Python and install IPython. And then in the app images, app1 and WAP2, I've put from foundation, blah, 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 blah. So the idea is basically that we start by building that foundation image, that common base, and then we build the application images using that. And there are some other little details here explaining, like, the pros and cons and some little details about this approach. The reason why we would do that, honestly, it's not really about the size of the Docker file, because even in the worst case scenarios, Docker files will not be super, super big. Honestly, I don't think I've seen normal Docker files being more than 100 lines, and that's even like a lot. Usually it's going to be maybe 20, 30 lines. And if you have a longer Docker files, generally it's not because you have tons of steps, but you could have like one layer, one command that would take multiple lines. So where I'm getting at is that the problem is not really the size of the Docker file. It's more like how long it takes to build it. And I'm going to give you like the, well, I don't know if we could say the perfect example, but a very good example of that. When you do data science, machine learning, you could install some really big libraries, stuff like PyTorch, SciPy, etc. And so you could have like these really big libraries, and then you have maybe 10, 20, 30 applications that use these libraries, and then you just add a little bit of code. So now when you look at it, you're like, that doesn't seem right, because I have 20 applications that have this pretty big Docker file, and there is like 90% of it which is the same, always the same between all these applications, and then there is just a few lines at the end that change. And I would like to follow DRY principles, DRY, don't repeat yourself. Very often when writing code, if we feel like we're writing the same thing over and over, it's a good sign, like maybe I could optimize something here. So in that case, it can be a good idea to work with a common base image to avoid rebuilding that same image lots of time, etc., etc. So that would be an example of how to do that. So that's how we would compose things. I've also seen sometimes folks use a preprocessor. So you have a Docker file and you kind of cat multiple Docker files. I'm not a huge fan of that. Of course, it's possible. Nothing prevents you from, generating a Docker file with a shell script and etc. The reason why I'm not a huge fan of these approaches is because we have many tools in the Docker ecosystem in general that are going to work, for instance, on a repo. Let's say you have a repo on GitHub, GitLab, Bitbucket, etc. And you have tools that are going to get that repo and build the Docker file. So now if you start by generating your Docker files with a little shell script, you won't be able to use these tools, at least not directly. And so as much as possible, I try to stick to this idea of we have a repo, we have a Docker file, and we build like this without adding too many kind of weird custom steps before or after, at least when possible. All right, so second question, is the homework in the slides deck? Yes, the homework is on the last, that's the last item here. And there is actually a link to another repo. And if we go to that repo, you have instructions in English and French, and you have all the details. And the homework for today is just exercise 1, writing Docker files. I'm going to talk about that again when we get there in about 50 minutes. Okay, first, let's take a short 5 minutes break. And then after that, we're going to talk about Dockerfile commands like cmd, entry point, copy. And with that, we should have everything we need to build our first container images. See you in 5 minutes.